In this section, we're going to learn about matrices and how to find the determinant of a square matrix. It feels like a bit of a departure from the systems of equations that we've been working with, but we'll see in the next section how this can be used to help us solve systems of equations. It's another technique to solve a system of equations, and it's one that is particularly effective for larger systems. So a matrix is just an array of numbers. So you have numbers arranged in rows and columns. We usually put brackets around them, or sometimes people will put like a big set of, parentheses around them. But, you kind of have these grouping symbols. So then you got some rows and columns with numbers. Here's 3 matrices. We usually use capital letters to denote a matrix. So we've called these capital A, capital B, capital C. And often we'll use a lowercase letter with some subscripting to reference the actual entries, the individual numbers that appear in the matrix. We'll see that in a little bit. If we have a matrix, say we have a matrix A, the dimensions or size of the matrix is n by m, where n is the number of rows in the matrix and m is the number of columns. It's always the number of rows goes first. And we write dim A is n by m. If we have a matrix with an equal number of rows and columns, so like say its dimensions are n by n, we call that a square matrix of order n. So if I wanted to write out the dimensions of the matrices in the example up here, well, the dimension of A of this matrix, well, I've got 2 rows and 3 columns, so that's 2 by 3. And we leave it like that. We write it as 2 by 3. We do not multiply and say, oh, the dimension is 6. That doesn't describe the matrix, the dimensions. The dimension for matrix B, there are 4 rows and 3 columns, so this is 4 by 3. And the dimension for matrix C, well, that's 3 by 3. And so we would also say that C is a square matrix of order 3. The position of an element, like an entry and an actual individual number that appears in the matrix, we give that position by using a double subscript. Say little a sub nm, that's the number in row n, column m. Again, it's the row that comes first. So here's a matrix A. It's the same one that we saw above. A21, well, that's the element in row 2, column 1, so that's 7. A12, that's row 1, column 2, and that would be -4. And A23, that's row 2, column 3, that's this entry right there. Now if somebody said find A32, they're saying give me the element in row 3, column 2. Well, there is no row 3, so A32 does not exist. Any square matrix, we're going to focus mostly on square matrices here. If we have a square matrix, we can compute its determinant. And a determinant is a single value that is associated with a square matrix. First, we're going to learn how to do this with 2 by 2 matrices. And then we're going to extend that and learn the process to find it for larger matrices. So if we have a 2 by 2 matrix, the determinant, which we denote by either det of A, like determinant of A, or with those pipes, like just kind of like absolute values around A. It's not really an absolute value. You'll see there are determinants that end up being negative, all right, but this refers to the determinant of the matrix. So if I have a matrix with entries A, B, C, D, so there's a 2 by 2, and I want to find the determinant. Again, notice these straight vertical lines. That means I'm looking for the determinant. You're going to take you're going to multiply along what we call the principal diagonal, top left to bottom right. So you get AD, and then subtract what you get when you multiply along the other diagonal, B times C. In these first two examples, let's see, this part A, we want the determinant of the matrix, negative 5, 8, 3, 7. So I'm going to multiply this way, negative 5 times 7 minus 8 times 3. So that's negative 35 minus 24, which is negative 59. In this other matrix, let's see, the principal diagonal, that's negative 3 times 4, and we're going to subtract 9 times negative 2. So we get negative 12 plus 18. We get a determinant equal to 6. So finding the determinant of a 2 by 2 matrix is really pretty simple. It takes a little practice. Like, it's easy, it's simple to do, but can be easy to make a mistake. You got to watch out for your signs. It's easy to make a sign error. Now, for bigger matrices, what we're going to do is sort of relate that matrix to some nested, like 2 by 2 matrices. This procedure is going to feel a little bit more complicated. We do have to kind of try to be organized with our work here because, again, it's not difficult to do, but it can be easy to make mistakes. So practice is key. So before we talk about getting the determinant of a bigger matrix, like a 3 by 3, for example, we're going to note that in a square matrix, each element has an associated minor. And what a minor is a determinant of the matrix you get when you eliminate the row and column of that entry. So here's an arbitrary 3 by 3 matrix, right? I've got this matrix A. I populated it with just arbitrary entries. So I've got A11, A12. You notice I'm using those double subscripts just to indicate the position. Now M21 is the determinant of the matrix that I would obtain if I eliminate the row and column of the entry A21. So if I eliminate that row and that column, I'm left with these 4 entries. I'm left with that 2 by 2. Notice that's what we have showing up here, and we just find that determinant. Now the cofactor is given by, so in the definition here, for the cofactor, it's given by negative 1 raised to the I plus j multiplied by the minor. Basically, it's just whatever that minor is, and then it'll either be the same sign of the minor or a different sign. Negative 1 to the I plus j is either going to be positive 1 or negative 1, depending on whether that exponent ends up being even or odd. So in the event, in this example where we are looking at M21, we have that we have this minor, and its cofactor is negative 1 to the 2 plus 1. Well, that is equal to negative 1, right? That's negative 1 cubed. That's negative 1, and so we get negative M21. Whatever the value of that minor is, we change the sign. If we were to look at another minor, I'm going to do some erasing here. M22. Well, here we're looking at A22, and so if we eliminate that row and that column, then the entries we're left with are A11, A13, A31, A33, and we put those entries in a 2 by 2 and find its determinant. That's the minor. Now, the cofactor in this case is going to be equal to the same value as the minor, because negative 1 to the 2 plus 2 is negative 1 to the 4th, and that's positive 1. So the cofactor is either going to be equal to the minor or just a different sign. And that pattern, it'll follow a certain pattern. And in fact, here's the pattern of signs for whether the cofactor is the same sign as the minor or a different sign. And that all has to do with whether the subscript, I plus j is even or odd. But I just remember this pattern of signs. In fact, I almost never actually write out like the formula like this where I have -1 to the 2 plus 2. I just pay attention. I just jot down this pattern of signs and pay attention to what that tells me it should be. So far right now, what we're doing, it feels like we're kind of getting away from things a little bit. We're kind of looking at these minors and cofactors, and we haven't even talked about finding the determinant of a 3x3 matrix, and we're getting to that real soon. What I want to do first is just an example. Here's a 3x3 matrix, and we are being asked to find the minors and cofactors for elements in the first row. So I'm just going to, for each of these elements in the first row, I'm going to find the minor and cofactor. So for the first row, M11, that is the determinant of a 2x2, and it's the 2x2 that I get if I eliminate the first row and first column. So that's, I'm just going to take the remaining numbers, -1, 2, 0, 1. And let's see, that is -1 times 1 is -1 minus 2 times 0 is 0, and that's -1. That's the minor. Now what about the cofactor? I know the cofactor is either going to be the same as the minor or a different sign. So look, here's my pattern of signs. And we're in the first row. Right now that sign for the 1-1 entry is positive, and what that means is that the cofactor is the same sign as the minor. And so this will be, the cofactor is -1. For the next entry, the minor for 1, 2, here I'm going to erase some of this. I know it's going to be the determinant of a 2x2. And it's the 2x2 I get when I eliminate the first row, second column, and that'll be, the entries I'm left with are 3, 2, 4, 1. This determinant, 3 times 1 is 3, minus 2 times 4 is 8, so we get -5, and it's cofactor, so that's the minor. Now the cofactor, 1, 2, now I look at that entry in the pattern of signs. Right here, that says change the sign. If it's a negative, I'm going to change the sign of the minor. So that's a +5. And the minor for the last entry, so we're looking at 1, 3, so that's this entry here. I'm going to eliminate that row and that column. The minor 1, 3 is the determinant of the 2x2 that remains. Oops, should be a -1, 4, 0. So multiply 3 times 0 is 0, minus -1 times 4 is a -4. So 0 minus a -4 is +4. And that's the minor. The cofactor, well, looking at the pattern of signs, that's a plus, and that means the sign stays the same. So the cofactor is the same sign as the minor, so the cofactor is +4. Here we found these cofactors. Now what does this have to do with finding the determinant of a 3x3? And that's given in the following definition. So for any square matrix of order greater than or equal to 3, so if I have a 3x3 or a 4x4 or a 10x10, we find the determinant of that matrix. One way to do it is to, we say, expand on the first row. So I take each entry of that first row times its cofactor. Each entry of the first row times its cofactor, and then I add them all up, right? That's what this says. In this definition, we're expanding on the first row, but if this works, you can expand on any row or any column. that you want. And that's important. There are going to be easier choices we can make to find the determinant of a matrix. Here we have now a matrix. It's the same one that we just found these cofactors for. And we're being asked to find the determinant. We're going to do this in two ways. All right. We're going to do this by using those cofactors and this formula here in this definition. And then I'm going to show you kind of how I streamline the process just to get the determinant of a 3 by 3. So if we expand on the first row, right, those are the ones we found the cofactors for. So let's expand on the first row. This says I'm going to take the first row entry, 0 times its cofactor. That cofactor was -1. Plus the next entry is 2 times its cofactor, which is 5. Plus the next entry is 1 times its cofactor, which is 4. And I just add these up. So 0 times -1, that zeroes out. 2 times 5 is 10, plus 4, we get 14. So that took a bunch of work, right, to work through. I did all this side work. You can kind of roll all these calculations into one go. And I'm going to show you how I would do that here. And it's going to be the same matrix. So we're still going to get the same determinant, a determinant equal to 14. First thing I do, I jot down the pattern of signs. And if I find the determinant by expanding on the first row, what I'm going to do is take each entry. So I start with the first entry, which is 0, times the determinant. Let's see, it's minor, which is the determinant of that 2 by 2. And that 2 by 2 will be -1, 2, 0, 1. Next, looking at the pattern of signs up here, that's a negative, so I'm going to subtract. Then I'm going to take this next entry, 2 times its minor. And if I eliminate that row and column, that leaves me with 3, 2, 4, 1. Next, in the row of signs is a plus, so I'm going to add. And then my next entry is 1 times its minor, which is 3, -1, 4, 0. This, what I've just done right here to set up, rolls in all the stuff that we just did in the last example and in the definition where I added them together. I'm just sort of putting it all together and using the pattern of signs here to determine whether each of these is plus, minus, plus. So this is clearly, the first one is 0, right? Like I'm taking 0 and I'm multiplying it by the determinant of that matrix. Who cares what the determinant of that matrix is? I'm multiplying it by 0, so I'm not going to bother. And then minus 2 times, let's see, 3 minus 8 plus 1 times 0 minus a -4, so plus 4. So that's 0. 3 minus 8 is -5, so I have -2 times -5. Plus 1 times 4 is 4, and that gives me 14. Obviously, the same thing that we got up here. All right, I'm going to show you, the next page is just tells us how to find the determinant of a matrix on our TI-83 or TI-84. And we're going to do that. I'm going to show you how to do that for this matrix here. Again, this page has the steps, so you can kind of refer to that. I'm going to show us how to do it on this matrix. We're going to use this as a check. Please note that when I'm asking you to find determinants, you'll probably see the instructions evaluate the determinant by, expanding by cofactors. And so you need to use this technique that we've been learning. But the calculator is a great way to check our results. Oops. So the first thing I'm going to do is get into the matrix menu. On the TI-84, I hit the second button, and then this x to the -1 button above there in blue is matrix. And I need to edit a matrix. That's what's going to allow me to put in numbers. So I'm just going to put this in matrix A. This matrix is a 3 by 3. That's the first thing it wants, is the dimensions, 3 by 3. And as I enter those dimensions now, you'll see there's a spot to put those 9 entries. So I'm just going to put those in. 0, enter, 2, enter. As you hit enter, it just kicks you into the next cell. Alright, so that's entered. Now what I'm going to do is quit to the home screen. It's important to quit to the home screen, even though I'm going to go back into the matrix menu, because I don't want it to think that what I'm calling, when I'm asking it to compute, I don't want it to enter it into the matrix. So I'm doing this from the home screen. I'm hitting second matrix again. This time I'm going to do some math. So I arrow to the math menu. The very first option, DET, for determinant. And then finally, one more time in the matrix menu, this time to select the matrix, matrix A, closing the parentheses, and there's our determinant, 14. I'm going to show you one more example, because I mentioned that we can expand on any row or column that we wish. And there are choices we can make that will make our jobs easier. So this is a bonus example. We're going to find the determinant of this 3 by 3. And we're going to pick a row to expand on. And I'm going to pick row 2. I'm expanding on row 2 because there's a 0 in that. If you are finding the determinant of a 3 by 3 matrix, pick a row that maximizes the number of zeros, all right? That will reduce the amount of work that you have to do. So I'm expanding on row 2. The next thing I'm going to do is just jot down, here's my pattern of signs. And since I'm expanding on row 2, that's the pattern of signs that I'm going to use. Notice that in row 2, that begins with a negative, so I'm going to write minus, and then my first entry is a 9 in that row, times the determinant of the 2 by 2 that I get when I eliminate that row and column, or that row and that column. So that's 3, -6, -6, -2. My next sign here is a plus, so I'm going to do plus. My next entry in the matrix is a -2, and its minor is the determinant of the matrix I get if I eliminate row 2, column 2. So that leaves me with the entries -1, -6, -4, -2. And then my last sign here is negative, so minus. And then I have my last entry is 0 times the determinant of, who cares? I'm not even going to write it down because I'm multiplying it by 0. The whole point of picking a row with a 0 is that I don't have to find that other minor right there, okay? So the rest of this is computation. I'm going to carry out, find these determinants of the 2 by 2s. So we get 3 times -2 is -6 minus -6 times -6 is a positive 36. So -6 minus 36 plus a -2, that's -2 times -1 times -2 is positive 2 minus -6 times -4 is positive 24. And this just zeroes out, so I'm not going to worry about that. The rest of this is arithmetic. So negative 9 times, let's see, this is negative 42 minus 2 times, this is negative 22. Negative 9 times negative 42 minus 2 times negative 22 is positive 422. And that's the determinant.